All right. This lesson it corresponds with section 7.2 in the book, Properties of Rational Exponents. So we've talked about exponents. Rational numbers are fractions. So I know that that's your favorite thing to deal with, right? So I wanted to review some fraction rules. Um, what I have here is it's called a close. There's a bunch of blank spaces and there's a word bank in the bottom. I want you to pause for a second and you can write down the notes. You want to fill in these words down here in the word bank in these spots right here. So decide where each of those goes, hit pause, and then the answers are on the next page. All right, so hopefully you hit pause. All right, so in order to add or subtract fractions, they must have the same denominator. In this case, they do have the same denominator. You keep the same denominator and add or subtract the numerators. So I'm talking about a third. A third looks like this. The piece that is a third looks like that. So I have 2 of those thirds and I have 5 of those thirds, and if I add them up in total I have 7 thirds, and I'm just leaving it as 7 thirds for now. Down here when we multiply fractions, we're going to multiply the numerators straight across. It's almost like I extend this line. 2 times 5 is 10, and 2 times, I'm sorry, that's a 3. 3 times 2 is 6. I also want to be careful to simplify. 10/6, they're both divisible by 2, so this becomes 5 thirds. Alright, so that's a quick review of fractions. I have a bunch of practice I can give you guys if you're struggling with fractions. Another thing you need to know in order to be successful with today's lesson and our next couple lessons is you need to really have a strong foundation of these laws of exponents. We've worked on them for a couple days in class, but I want you to pause again. I want you to pause. Make sure that you know these laws. So pause for a second, write down the laws, and then check and make sure that you got them correct. And that's what you should have gotten. This is an A, kind of looks big. Okay. So 2 powers with the same base. When we're multiplying, we add the exponents. 2 powers with the same base, we're dividing. We subtract the exponents. Anything to the 0 power is 1. This power applies to both the x and the y. And when we have a negative, we never want to leave something with a negative exponent. It needs to become its reciprocal. Alright, so we're going to use all of those properties and what we know about fractions to work on some problems. So let's say we were given, I have the laws of exponents written down here just for reference. If I needed to simplify this, it looks really confusing because I see all these fractions, but really it's the exact same process. I have 2 bases and they're identical. Same base, same base. Well, I keep the same base and I add the exponents. So I'm going to take 12/5 plus 3/5. I'm talking about the same size piece. They're all fifths, so we're good to go. And I need to just add the numerators. So 12 plus 3 is 15. And I don't want to leave it 15/5. I want to simplify and make that 3. So I end up with c to the 3rd power. Alright, I want you to try a couple. I want you to try number 18. The answer to 18 will be on the next slide. Number 19, if we multiply here, we have q to the 1/2 power to the 3rd power. So it's a power to a power. We're going to multiply q to the 3/2. 3/2 power. That really is like 1 over 2, 3 over 1. I'm multiplying straight across. 1 times 3, 2 times 1. Q to the 3/2 power. Now, this one is also pretty simple. The denominators are the same. But over here, we have different denominators. So we need to get those denominators the same. Here, same base. I keep the same base, and I add the exponents. So 1/5 plus 1/2. But I'm not talking about the same size chunk, same size piece. I need to be talking about the same size piece. So in this case, I'm going to use 10 as my common denominator. To get from 1/5 to some tenths, I need to multiply by 2. Really, I'm multiplying by a form of 1, 2 over 2. 5 doubled gives me 10, and 1 doubled gives me 2. So I'm changing that to a like fraction. All right, 1/2, if I multiply this by 5 over 5, I will get 5/10. Now I'm ready to add them up. So I get p to the 7/10. And I leave the denominator the same. That tells me the size of piece, and that tells me how many of those pieces. All right, same thing applies here, except now I'm going to subtract. I'm going to take x to the 2/3 minus 1/4. 2/3 minus 1/4. You guys know Dora the Explorer on that cartoon show? They have these pauses where you're supposed to fill in the blank, like you're at home and you're talking to your computer. Well, this is one of those times. X to the what? What power would we have right here in our denominator? Good, 12. All right, so we're going to pick 12 because 3 times 4 is 12. So to get from 3 to 12, we multiply by 4. 4 times 2 is 8. To get from 4 to 12, we multiply by 3. And we're subtracting. 8 minus 3, we're talking about twelfths, so we get 5/12. So the same exact laws apply when we're dealing with rational exponents. We just need to deal with fractions. All right. If you want to try the rest, I have the answers on the next slide, so give yourself a minute. Here you want to maybe combine 2 first, and then combine this way. All right, try them. And here is what you should get. And that is it.